But for a combination, order is not important, but again sampling is without replacement. So for permutations, order is important, sampling is without replacement, and for combination, order is not important and sampling is without replacement. Now we are going to see if to see that we can obtain the number of these permutations and combinations from the formula. So look at the formula again. N factorial n minus k factorial. So for permutation, we have permutation 2 out of 3 is n factorial n minus k factorial. It means is 3 factorial, 1 factorial, and it's 3, 2, 1, 1, it's 6. You can see here we have 6 permutations. But about combination, the formula is n factorial, k factorial, n minus k factorial. So here we have the combinations of 2 out of 3, so is n factorial, k factorial, n minus 2 factorial. So it's 3, 2, 1, 2 factorial is 2 times 1, and 3 minus 2 is 1, and 1 factorial is 1. So the result is 3. Here you can see we have 3 combinations of 2 out of 3. Again, look at this example. Arrange 3 out of 5 distinct marbles. So here select 3 out of 5. So it's a keyword. Select is a keyword for combinations, and arrange is a keyword for permutation. It shows order is important here, and here order is not important. But n is 5, k is 3 in both of them. Okay. Permutations 3 out of 5 is n factorial, or 5 here, n minus k factorial. This one is n, this one is k. So it's 5 factorial, 2 factorial, it's 5, 4, 3, 2, 1, 2, 1. So it's 60. But for combinations of 3 out of 5, or select 3 out of 5, it's 5, 3. Again, this one is n, it's called, or also we can write as this. It's n factorial, k factorial, oh sorry, it's k is 3 here, 3 factorial, and 5 minus 3 factorial, it's 5 factorial, 3 factorial times 2 factorial, and it's so and this one is 2, so the result is 10. Also, you can use calculator for computing combination and permutation. You can check with your calculator. But now, what is the relationship between permutation of co-objects out of n distinct objects and combinations of co-objects out of n distinct objects? Look at here, it's the definition of a permutation of co-objects out of n. Any ordered sequence of k objects taken from a set of n distinct objects is called a permutation of size k of the objects. So, in the first step, we have n objects, but we want to write the permutations for co-objects. So the first step is choosing or selecting co-objects out of n objects. Choosing and selecting co-objects out of n object is the definition of combination. So at first, we are going to select or choose co-objects out of n object, and it's the product principle, and after that we are going to order all of the co-objects, or we are going to arrange all of the co-objects. Arranging co-objects out of co-objects is k factorial. Okay, it's the formula for combination times k factorial, and this one you can see the result is the permutation of k objects out of n. So for permutation of k objects out of n, the first step is selecting or choosing k objects out of n, and then we are going to arrange all of that co-objects. Arranging co-objects out of co-objects is k factorial. In this slide, you can see some special cases that give you a chance to obtain the results quicker. Look at this example. We have 10 boys, a group of 10 boys and 8 girls, and we are going to select 3 boys and 3 girls from them. We want to see in how many ways we can select 3 boys and 3 girls out of 10 boys and 8 girls. Okay, you can see the keyword select. Selecting is a combination. So at first we are going to select 3 boys out of 10 boys, and then we are going to select 3 girls out of 8 girls, and by using product principle we can obtain the results. Look at here. Three boys out of 10 boys and 3 girls out of 8 girls. It's 10 factorial, 3 factorial, 10 minus 3 is 7. And here is 8 factorial, 3 factorial, and 3 out of 8 minus 3 is 5 factorial. Okay. Okay, there are 6,720 ways to select 3 boys and 3 girls from 10 boys and 8 girls. Now look at this exercise. Again, there are 3 boys and 8 girls, and we are going to select a group of 6 people from them. The gender is not does not matter here. So again you can see choose. We have chosen a group of size 6. So it's combination, selecting a group. You can see both of keywords here. What is the probability? It's not a counting problem, it's the probability. What is the probability of 3 boys and 3 girls in the group? So we need at first the number of outcomes in S. But for calculating the number of outcomes in S, just look at these 2 red lines. A group of 6 people from 18 people. For obtaining the number of outcomes in S, here the gender is not important, so we are going to select 6 people from 18 people. So NS is selecting 6 people from 18 people. But number 1, the probability of 3 boys and 3 girls in the group. Okay, so NA is 3 boys, and now gender is important. 3 boys from 10 boys and 3 girls from 8 girls. So the probability of A is you can use calculator to obtain the result. Number 2, what is the probability of just 2 boys in the group? Okay, so again, for number 2, again, NS is selecting 6 people from 18, and now 2 boys in groups. 2 boys in group. So we are going to select 2 boys from 10 boys. Okay, but we need 6 people in the group. Now we have 2 people, so we need 4 girls from 8 girls. So the probability is, for example, the probability of B is just 2 boys, so we need 4 girls, because in group we have 6 people. You can see again, 10 and 8 is 18, 2 and 4 is 6. Here 10 and 8 is 18, 2 and 4 is 6. Number 3, what is the probability of at least 1 girl in the group? Okay, again, NS is a group of 6 people out of 18 people, and we need at least 1 girl. Okay, at least 1 girl is, it means 1 girl, 2 girl, 3 girl. We have, please note that we have 10 boys and 8 girls. So at least 1 girl, it means 1 girl, 2, 3, 4, 5, and 6, because there are 6 people in the group. So it's better, instead of calculating the probability for at least 1 girl, we use the proposition 2, and we can use the proposition 2 to obtain for example, to obtain 0 or no girls in the group. So the combination, the complement of this set is no girl in the group. If it's, for example, C, this one is C prime. We know that the probability of C is 1 minus probability of C prime. So we are going to calculate the probability of C prime. It means no girl in the group. So no girl in the group, it means 6 boy from 10 and no girls from 8. So the probability of C' is 6 boys from 10 and no girls from 8, 6 people from 18. So by using this probability and this equation for position 2, we can obtain the probability of C.